This video will present solutions to the VCE 2024 Mathematical Methods Written Examination 2, Section B, Question 3. This question involves functional models for this set of online sales data. In Part A, we are asked to fit a cubic P of t to this data, based on the fact that P of t has a local minimum at 2,2500 and a local maximum at 11,4400. To do this, I'm going to define the general cubic P of t in my ClassPad, using x instead of t, and using the variable keyboard to access A, B, C and D, and then defining via the interactive menu. With that done, we can define a system of 4 equations based on the 2 stationary points given. These equations will be that P of 2 equals 2500 and P of 11 equals 4400, and that the derivative of P of t is equal to 0 when t equals 2 and also when t equals 11. It is important to write down these equations rather than going straight into solving them, as this question is worth 3 marks and so it is expected that working will be shown. To solve these equations simultaneously on a ClassPad, first tap the simultaneous equations icon on the Math 1 keyboard 3 times. Now, using a little drag and drop, enter the first 2 equations. For the third equation, enter the derivative template from the Math 2 keyboard and drop in P of t. Now equate the derivative to 0 and substitute in the value x equals 2 using the given that symbol from the Math 3 keyboard. The fourth equation is a swipe, drag and drop copy of equation 3, changing the x value from 2 to 11. With the system of equations defined, they can be solved for A, B, C and D. As we need the answers to 2 decimal places, tap on that output line and tap on the exact decimal icon. In Part A, Part 2, we need to translate this cubic so that its maximum, which was at 11,4400, is translated to 23,4750. As such, with a little subtraction, we can see that h equals 12 and k equals 350. In Part B, we are introduced to another function that can be used to model this sales data. In Part 1 of this question, we need to finish off this function's incomplete graph and label its endpoint. To help me do this, first I'm going to enter the expression for f into my ClassPad's main app. With that done, I'm going to tap the graph icon from the top toolbar. To make sure I obtain a graph that matches the one given, I'll now tap the view window icon and enter the x and y minimum, maximum and scale values just as they are in the given graph. With that done, I'll select the expression for f and drag it into the graph window. This shows us that the graph we need to draw is a continuous extension of what has already been drawn, showing 3 replications of a W shape, with an upward linear trend due to the 30t term. We are told to label the endpoint of our graph with its coordinates, so we better do that. I'm going to tap the trace icon at the right hand end of the toolbar, then type in the x coordinate of 36, giving me the y coordinate of the endpoint. In Part 2 of this question, we are told that every 12 months, sales increase by N million dollars, and we are told to find N. This increase is due to the only part of the function f that is not periodic, which is the linear term 30t. As such, the increase in sales in 12 months is 30 times 12, which is 360. This result can also be found by comparing function values at equivalent points in the sales cycle. One way to do this is to use analysis GSolve to find maximas. There is one with a function value of 4100 and another with a function value of 4460 12 months later, giving us that increase of n equals 360 over a 12-month period. Part 2 of this question asks for the derivative f-t. I'm going to find this using my ClassPad by swiping the previously entered expression for f and choosing Differentiate from the interactive calculation menu. In situations such as these, I like to tap Simplify to make sure I am transcribing the nicest version of the result. To help with transcription, it might be worth tapping Rotate on your handheld's never disappearing toolbar to see the function in full. If you are working with x in place of t as your variable, as I am, don't forget to use t when you write down f-t. The final part of question 3 asks for the maximum instantaneous rate of change of f and the times at which it occurs. One approach to this is to apply the fmax command to the previous answer, being the derivative, over the domain from 0 to 36. Doing this, we see that the maximum instantaneous rate of change value is $725 million per month, and this occurs when t equals 22.2 months. This result is somewhat odd, as the derivative is strictly periodic, so this maximum value should occur every 12 months. Fmax has missed the maximums 12 months earlier at t equals 10.2 and 12 months later at t equals 34.2, probably because it is working with decimal approximations to function values. We will need to make sure we include these additional two solutions, which could be confirmed via a graph if desired.